Hi, my name is John Paul Raj, and I'm on a mission to make the learning of math fun. So if you're new to this channel, please do consider subscribing. This is part 4 of sequences and series. And on this part, we're going to talk about arithmetic sequences. Let's start. Okay. An arithmetic sequence, also known as an arithmetic progression, is a sequence of terms where each consecutive term, each successive term, differs by a constant difference. Between each two consecutive terms, when you subtract the two, there's going to be some value, right? But that value that you get when you subtract two consecutive terms is going to be the same. That's what we call a constant difference. If there is a sequence like that, then that sequence is called an arithmetic sequence. So in general, what it means is that if you have U1, U2, U3, ... UN, and let's say the next term after UN is UN plus 1, and let's say it's you've got an infinite sequence. And what we said is that when you subtract into numbers, U2 minus U1, you'll get a number, you'll get a value, right? A difference. That difference between those first two terms will be the same as the difference if you were to take the difference between the next two terms. That means it should be U3. It should be U3 minus U2. Can you see that? So the difference between U2 and U1 will be the same as the difference between U3 and U2. That's the meaning of constant difference. The difference between two consecutive terms is going to be the same. And it will be the same even if you take the difference between, let's say, the next two terms. Okay, U4 minus U3. And in general, you can say that because UN represents the general term, right? So you can say the difference between UN plus 1 minus UN. Can you see this, what I'm writing? Yeah. UN plus 1 minus UN is going to be a constant difference, and they're going to be the same. This is going to be the same as these differences. We denote that constant difference by the letter D. Okay? This letter D denotes what we're going to call the constant difference. So if there's a sequence of numbers where the difference between consecutive terms is the same, equals, U1, U2 minus U1, U3 minus U2, U4 minus U3, it's the same, and it's the same for every term. That means UN plus 1 minus UN is going to be the same. We represent it by D for that constant difference. Okay, let's take an example or two to understand. Okay, it says, show that the following sequences are arithmetic. Basically, what you're trying to show is that the difference between consecutive terms is the same. That's the basic definition, and we're just using the definition of arithmetic sequence to show that any of these sequences is the same. And then I think part 2 says find the common difference. Well, if you're going to see that the differences are the same, it's going to be the common difference that we are finding out. So let's do it. Okay, so the first sequence, as you can see, it's represented as a set. We already saw that in earlier videos. Let's see the difference between the second and the first term. So you've got 2, 6, 10, 14, so on and so forth. And we'll see the difference. So 6 minus 2 happens to be a 4. All right, that's the first two terms, the difference between the second term and the first term. Now let's see the difference between the third term and the second term. That's 10 minus 6 happens to be a 4 again. What's the difference between the next two terms? That's the difference between the fourth term and the third term. 14 minus 10, that is still a 4. And as you can see, that happens to be the constant difference. You see, between any two numbers, when you subtract any two numbers, you're going to get a difference, right? But the difference has to be constant, and that is the definition of an arithmetic sequence. That means by the definition, this sequence, therefore, this sequence is an AP. AP is just short for arithmetic progression, okay? So this is an arithmetic progression. Why? Because the difference between any two consecutive terms is a constant, and that constant common difference, they say, constant difference, common difference is that 4, okay, that we've calculated. That constant difference D in this case is 4. Okay, let's take another example. Okay, so this next example is a sequence of terms 1, -4, -9. So that is the next example. You got 1, -4, -9, and so on and so forth. Okay, those are the only 3 terms that they've given. That's the sequence. Let's find out the difference between consecutive terms. All right, so -4 minus 1. All right, it's always second term minus the first term. Now -4 minus 1 is going to be -5. Now the difference between the next two consecutive terms, that's the third term minus the second term. The third term happens to be a -9 minus, the second term is already a -4. So it's going to be -9 minus of -4, which is a -9 plus 4, again happens to be a -5. So as you can see, that difference is a constant difference. which is our D. Okay, so our D happens to be a -5, and therefore this is an AP. All right, so that is the definition of an arithmetic progression. When the difference between any two consecutive terms is the same, we call it an arithmetic progression. Now let's take some formulae. If you have an AP, all right, an arithmetic progression for an AP, the general term UN, the general term is given by the formula A plus n minus 1 times that D that we've just found out. A, remember, we've seen in earlier videos, A is your first term, right? We'll write it down anyway. A is your first term of that sequence, and the D is this constant difference. So once you know the first term and the constant difference of an AP, you can pretty much write down the general term using just those two parameters, the first term and the constant difference, as the general term U of n is equal to A, the first term, plus n minus 1 times the D. Let's put it into this examples that we just saw, right? So the example that we saw here was this 2, 6, 10, 14, all right? The difference we found out was 4, all right? That is the constant difference. The first term is 2, which means U of n for this sequence, do I have space here? Cool. So the U of n for this first example, U of n, is that first term, which is 2, this is the first term of that sequence, plus n minus 1 times the D, which we found was 4. And then, of course, you have to simplify it to give 2 plus 4n minus 4. And the general term is then 4n minus 2. All right, that's the general term for the first example that we saw. Okay, clear. First term and the constant difference. Put together, you'll get the general term with the formula A plus n minus 1D. Let's do the same thing for the second example we saw. The first term in this case was 1. And the constant difference we found was -5. Let's put it together to find the general term of this arithmetic sequence. So it's A, which is 1, plus n minus 1 times the D, which is a -5. All right, you got to simplify, not leave it there. Okay, so we write it as 1 minus 5n plus a 5, which will give us 6 minus 5n. That becomes the general term for this arithmetic progression. Now let's look at a different kind of an example, all right? So here we go. This is a question where it says that the 14th term of an arithmetic sequence is 100. It's given that it's an arithmetic sequence, and it's given that the 14th term of this arithmetic sequence is 100. Write it down, okay? So I would say, first write down, this is 6. It says this is an AP. I'll encourage all my students first state that, okay, if it's given as an AP, write it down as an AP, and then you can make use of the other parts of the question. And then it follows that why you're using a particular formula, okay? So it's a good habit to identify even this part of what is given in the sequence, if it's an AP or whatever type of sequence it is. What's the next thing they're given? They're given that the 14th term of this AP is 100. So you write down U14 is 100. Clear? Now, what else is given? Well, they've said that the first term is 9. In an earlier video, we have already seen that the notation for the first term for any sequence is A. All right, if you've not seen that video, I'm going to link that entire playlist. This is part 4. Okay, so we've already said that A represents the first term and A is 9 in this particular AP. Okay, what is asked? They said find the common difference. That D, find the common difference. So using this idea, let's do it. Okay, so what we have is the 14th term, right? So we can write in terms of A, U14 must be equal to A, which is 9, plus n minus 1, right? That was the formula n minus 1. That's 14 minus 1 times the D, which is the unknown. So then we make use of the fact that they've given us the 14th term, right? It's given as 100. So you just substitute U14 as 100, and that becomes 9 as it is. 14 minus 1 is 13 times a D, all right? And now it's just about solving for D. And so you'll get 100 minus 9 is equal to a 13D. 100 minus 9 is a 91 is equal to a 13D. And then when you divide on both sides by 13, you'll get the value of D as 91 over 13, which is 7, which means that the common difference or the constant difference is 7. All right, we're going to continue our discussion on sequences and series in the next video. See you in that one.